So the next we have the panel discussion on the topic, the role of biotech in shaping the future of crops. And to moderate this session, we have Mr. Gaurav Sharma, who leads the global agri-business research at Accenture, where he focuses on shaping the future of crop protection, fertilizer, and precision farming. Alongside with him, we also have Dr. Tom Adams, who is the co-founder and the chief executive officer of Pairwise, a pioneering company leveraging the CRISPR and the gene editing technologies. Alongside with them, we also have Mr. Deepak Parikh, who is the founder of HNYB Tech Incubations Private Limited and a globally recognized business leader, strategist, and technology evangelist. Last but not the least, we also have Sefer Achad, who is the co-founder and the chief operating officer of AgTech Media Group, where he co-founded the iGrow News in 2021. Please give them a huge round of applause and welcome them on the dais.
It's a pleasure to be here with such a distinguished panel, and I think lovely audience as well, though we are very thin. I think we'll start with a round of introductions. So Deepak, you'd like to start?
Yeah, sure. I am Deepak Parikh. I am founder of Honeybee Tech Incubations. So we are a boutique consulting firm which work on intersection of agriculture, food, technology, and innovation. Currently working with various public and private sector enterprises across the globe. So we advise governments on policy. We work very closely with farmers for creating cooperative-based, cluster-based approach for increasing their productivity, profitability, and ensure their better standard of life. We work with startup in guiding them actually for go-to-market strategy as well as the new product innovation. I'm a big fan of biotechnology, and as we go forward, right, we'll talk about it.
No,
it's green. There we go. You just got to wait a second. Great. I'm Tom Adams. As in the introduction, I'm a co-founder and CEO of Pairwise. At Pairwise, I think the easy way to think about what we're doing is using CRISPR technology as another NGT technology to make crops easier to grow and easier to eat. So I think it's pretty simple that that there's always the opportunity to do things for the grower. Often things in genetics and breeding improve situation for the grower, not necessarily as much for the consumer. We try to think about the whole system and improvements that we can do for both.
Hello? Yeah, that works. So I'm Sefer Achad. I'm the co-founder and COO of AgTech Media Group. As it was briefly mentioned, AgTech Media Group is the company behind iGrow News. We share the latest news and developments in the world of agriculture. And we also track a lot of information that we then leverage to provide market intel on funding trends and various trends that we can identify across the segments that we track.
Thank you very much for your introductions. I'll also introduce myself. So I'm Gaurav, and I lead the agribusiness research at Accenture. And I focus on themes such as future of crop protection, seeds, fertilizers, biologicals, precision farming, agri-biotech, and new farming methods like CEA and sustainable agriculture. And I work with most of the major corporates focusing on agrochemicals and agribusiness. So that's all about me, and now I like to set the context of our discussion. So as we know, agriculture is in a very, I would say, at an intersection of different forces shaping the world. So we are looking at population increase, we are looking at climate change, which is having an adverse impact on agriculture. We are looking at corporations focusing on sustainability and profitability. And right at the heart of it, we have biotechnology, which is driving this transformation for agriculture. So I'll start with you, Tom. Given your experience in plant sciences at both Pairwise and earlier Monsanto, can you elaborate on how biotechnology is going to drive the future of agriculture? And what are the agribusiness challenges we are trying to solve using biotechnology?
Yeah, I think just broadly, with plant agriculture, an awful lot comes down to the quality of the seeds and the performance of the plants that come from the seeds. And so clearly there's a has been amazing things that have happened in the last 10,000 years since the first hunter-gatherers were casting seeds and then coming back upon them and selecting varieties that happen to be a little bit better every year into then what's now become known as conventional breeding, and then with the technology of GMOs being able to make crops that are resilient to insects and reduce the amount of synthetic chemicals you need to use and all these kinds of things. I think the CRISPR technology has allowed us to move broader, and I think what we're definitely trying to do with Pairwise is to get beyond just the crops that we grow to feed to animals and actually make improvements on crops that we eat ourselves, which I think we can start to see the benefits of technology and improve things. So I think biotechnology on seeds is going to be core to creating crops that are resilient to environmental changes. We've created blackberries that can produce twice as much yield with the same amount of inputs in basically the same amount of land. So you can see how we can do things to continue to improve productivity in ways that help for more sustainable ag.
Very valid points, and I think biotech is also not working in isolation. So Deepak, yesterday we heard you talk about in the panel how crucial is AI in agriculture. So let me take it a step further. Given your experience across strategy, technology, and agriculture, how do you see biotechnology converging with AI and data systems or data innovations to redefine agriculture?
Yeah, sure. I always believe that actually, the future of agriculture is about code plus genes, right? The both need to be together, and then that is where the magic happens. When we talk about the advancement in artificial intelligence, it is already helping the biotechnologist, because you can do a lot of simulation, whether you're talking about precision breeding, whether you're talking about predictive phenotyping, or whether you're talking about AI-driven, right, genetic editing tools, right? All of them, they are already have ensured that what we used to achieve in maybe a decade, we are now achieving in a couple of years. So AI is already contributing that. Second area is that actually where AI and biotech work together is able to simulate different agroclimatical zone in a lab, right? And this is where actually you rather than spending so much of money from pot to the farm, you are able to reduce that cost. And when you are able to reduce the cost of creating something which is most important, talked about the seeds, right? I believe a good seed is 80% of the battle won. And if you are able to do that, AI and biotech, they are able to solve this problem. I would give an example of a company you might be knowing, Inari, right? And they have beautifully used artificial intelligence and CRISPR-Cas to come up with soybean which consume less of water and hardly need any nutrient, or for that matter wheat, which are actually heat tolerant. Similarly, Allsero, which is a company based out of Sweden, they've been able to ensure that they are able to grow the best possible rice and wheat in most arid and salty soils. So all those innovations are possible because you're having, I would say, convergence of these two very important technologies.
So which was the name of the company you mentioned?
So Inari is based out of US, and Allsero is in Sweden. In fact, in India also, there is a company called Absolute. Well, they are not specifically working on the seeds part of it, but they have done some very interesting work. I would also like to add one very small thing. See, few years back we were talking about GMO or genetic editing, good or bad or ugly or whatever, right? And its impact on health. And there was a lot of noise around I'm saying that whether this is good or bad. But today we are talking about food, feed and fuel, right? So at least at the last part of it, fuel, right? My car would not differentiate if it is coming from GMO or it is a non-GMO or it is genetically edited, right? So if I have to make ethanol, right, why I should be making, India is one of the largest producer and user of ethanol blending, E20 blending. Now suddenly I'm having a situation that actually I'm still using non-GMO maize, which is having 1/3 of the yield of a GMO maize, but converting it into ethanols, and my car don't differentiate. So I think we'll have to evolve. Technology is one part of it. The ecosystem needs far more rethinking.
Right, and I can assure you it was not few years back. I was just having this conversation with Tom at the lunch table and about GMO and gene editing and how safe they are. I think the usual questions everyone has, especially for the European Union, we have a different set of regulations and maybe some other countries as well.
Have you seen a monster actually from a US who has been eating GM corn? I'm yet to find one.
Okay. I agree. Tom can comment more on that.
Sorry, I couldn't understand everything that was said.
So he's saying that actually the health safety
Yeah.
of GMO, I think there is sufficient mechanism, and that's why I was just joking that I'm yet to see a monster when I travel to US who would have consumed GM soya or GM corn.
Yeah, one of my colleagues likes to joke about when you go to Europe and you go to a cafe and people with a cigarette say, "Oh, those GMOs are so dangerous."
Perfect. Okay, so Sefa, with your experience in the iGrow platform where you track thousands of developments, what do you think, which emerging biotech trends do you believe they have the most significant long-term impact on crop yields and sustainability?
I mean, it's hard to identify only one trend. I think it's several trends, and it's in no particular order, but first of all, we're seeing a lot of work around microbes, and the use of microbes, and the study around how microbes can also enhance, certain microbes can enhance plant growth and plant resilience in certain areas. We're seeing also a lot of work, obviously, in trait developments, leveraging CRISPR-Cas, AI as well, to identify new traits that could be used in certain areas. And there's also RNA and peptide-based crop protection solutions as well. So I would say these are like the three main themes that we've identified this year, at least since the start of the year.
Oh, perfect. And I think I'll come to the panel later on talk more about these technologies. Coming back to you, Tom. So I think gene editing and CRISPR, I think that's what Pairwise specializes in. And we are seeing that they're drawing massive attention globally as well. So can you give some, live examples or use cases of how do you see these technologies transforming the future of crop development in terms of yield, nutrition, and sustainability? And some real-world examples would be very helpful.
Sure. As I said, we're really trying to apply CRISPR across many crops in agriculture. So we've worked with Bayer and Corteva, two of the biggest seed companies. And we've been able to put a number of leads into. We worked with Bayer first. We have a number of things we put into their pipeline that, for instance, every ear of corn has basically 16 rows of kernels. There are mutations in corn that have been known for a long time that lose control of that and they become a big ball. We were able to use CRISPR technology to make some very small changes in just single amino acids within the proteins encoded and create ears that are 18 rows, 20 rows, 22. So you can then take those out and you find out that 16 is actually not the best, that it's probably 18 or 20. You get significant yield increases without any more inputs. We also were able to take soybeans and make them resistant to Asian soybean rust, which is a major killer of soybeans in South America. $3 to $4 billion fungicide industry, so they're testing those products now. And I think I've probably just recently planted them in Brazil to get a test on whether they work in the real environment. So those are some things in the big acre crops, but as I said at the beginning, I think one of the things that we really wanted to do with CRISPR is take a reset on technology, since I think there was maybe some things got in the way of acceptance of GMOs, and look at crops that people interact with more directly and try to make improvements that really help for people. So we looked in the fruit space, especially fruit and vegetable, and the types of things. Most of the world, people don't eat enough fruits and vegetables, and we talk about making more nutritious crops, but we also need to get people to eat the crops that are already nutritious. So we're trying to take away some of the barriers to that. And one of the things that's driven consumption of fruit has been getting rid of seeds. Now, that stone fruit still have pits in them. Berries, believe it or not, are stone fruit. Those are little seeds in those that get stuck in your teeth are pits. So we've been able to make a blackberry now that doesn't have a pit, so the seeds don't get stuck in your teeth. But we also made blackberries that are compact, so they can be grown much more densely, which is really what's driven yield in almost every crop, is that denser planting. Get higher yields, no more input, and I think starts making them possible to adapt to, for instance, greenhouse production and things, which blackberries, if you've ever seen blackberry plants. They're big brambles that are, you wouldn't try to grow them in greenhouses, but now you're getting the same number of berries on a plant that's 3 feet tall and you can walk along it. So I think these kind of changes can help to make production simpler and make consumers, give consumers an opportunity to eat things that they might not otherwise eat. I think, our approach to this is to be very transparent about technology, though, and give consumers choice. So, if we've used technology to create it, we want people to know we did it, be proud of that, and not hide it. And I think that was also an issue that happened with GMOs, that there was the fight against whether you label or not, and we're just want to take that fight right to the end and say, label it.
Thank you very much. Very interesting insights on the real-life use cases. And when you mentioned BlackBerry, I also thought about greenhouses or indoor farming. And that's an area of interest, especially for UAE or other Middle Eastern countries, because they import a lot of food. So they're trying to focus a lot more harder on controlled environment agriculture right now. So Deepak, we have talked about gene editing and CRISPR at great length with Tom. And there are like so many other biotech innovations. Sefa mentioned just now also RNAi, microbiomes, DNA marker breeding, assisted breeding, plant tissue culture. You have a lot of experience working in a lot of countries with the different set of agribusiness leaders. So what is your thought from talking to those leaders that which of these technologies has greatest potential and should be watched closely by the industry?
No, surely before we get into which technology, definitely I am saying that CRISPR-Cas is hands down, right? It's the most talked about technology, most invested technology, and highest valuation, right? If you are a startup in a biotech, right? If you are even able to spell CRISPR and Cas together and explain what it is, right? You get funded. That's a joke which is going on, right? In biotech VC circles. Now the biggest challenge actually, when we are having cryogenic engines, right? We can use it to send people on moon and explore, or to Mars and explore, or maybe in future to explore what's there. Now, if the same cryogenic engine is used to create the most deadliest missile ever, right, then it comes the policy, ethics, and the society thinking about it. I'm a big fan that actually when we try to make agriculture sustainable by reducing usage of water, inputs, right. Also, I'm a big fan when we are trying to increase yield per acre, right. I'm not a big fan when actually we say that to enhance automation, I'm changing the structure of the plant itself. My apologies, blueberry or mangoes without seed, right? The nature has created seed to pass on DNA to the next generation of the plant itself, right? And now what we are trying to do is that we are trying to, for various reasons, right? Commercial reason, easy to eat, convenience, right? Human beings have been most stupidest of animal in the world. We have ensured that we are living in Earth. Now we are talking about climate change. We are talking about pollution. We are saying that whether we will be surviving after 100 years or not, right? We created that. So I can have a view that I need something as a consumer. It might not be good for overall evolution of our species. So we have to be very careful on that. And I think we are doing far too many experimentation around that. Second is that actually every country is having a different problem statement, right? How do you ensure that actually the global south, global north eventually meet somewhere? Or do we live in a philosophy that actually global north will always exploit and consume far more at cost of global south, right? That is where we are getting into, right? Because we don't want to pay labor in global south, right? We are trying to ensure that automation happens in global north, so that their food become cheap, and that actually those who are living in global south eventually are dependent on the food subsidy from the global north. So that is also very important. Technology can be a very strong weapon. We have to be very careful about the policy. Now, as I said, CRISPR-Cas, luckily in my own country, India, right, we have done SDN1 and SDN2 are to be treated as non-GMO. So the regulatory oversight is not there. You can it can be just like any other breeding, and you can use those seeds and start production. The challenge comes where the seed sovereignty becomes an issue, right? 80% of the food consumed in the world is produced in global south, because definitely population is also very high there, so they consume more. Now when we look at these technology, until unless we don't have open biotech infrastructure, right? What we are doing is that we are giving power to some of the monsters. We have seen those monsters in past, right, who create seeds which need specific type of pesticides, specific type of treatments, and then they monopolize the market, right? So we have already seen that once. We have to be very careful. We again don't repeat that mistake. Initially it was mistake. Now if we do it again, that would be stupidity. So I love definitely CRISPR-Cas, but I think that it is very important that the policy makers, they look at it and have a very strong oversight on what is being done, and actually even cross-border. For example, like GMO of XYZ variety were being used in Bangladesh long back, the brinjal and all that. They crossed border. Even my country didn't want it actually to experiment with GMO that time. Eventually, the market started fighting with that. So I believe we live in a world which is actually pretty globalized, and these things need, I would say, a conscious discussion at the level of cooperation at the multilateral level. Otherwise, we have serious problems in our hand.
So, Tom, would you like to respond?
I just comment very simply. You're right that it's a very complicated set of systems, but I would say be careful what you regulate. I think the reason that the GMO corn is controlled by just a couple of companies is because it costs $150 million to deregulate an article of corn. Take away some of those regulations for perfectly safe crops, and Indian universities could be producing insect-tolerant corn, for instance, that you wouldn't need to have the big producers doing it. The infrastructure has a lot to do with other things, but the problems are very complicated, and I don't think you should just look for the government to fix them.
No, sure. So I totally agree with you here. So when we talk about, that's why I said open public biotech infrastructure, right? You cannot leave research in the hand of only private sector, which always say that because I've invested so much in R&D, I have to recover my cost, and hence I would actually ensure that I'm having a restriction. But unfortunately or fortunately, agriculture leads to food. Every person in this world consumes food. So what is being done in US or what is being done in Europe is going to impact someone in Malawi, or is going to impact someone in Sudan, or would impact someone in Zimbabwe, which are not very possibly low capita countries. Now if we start putting the same level of I'm saying the profitability across the line, you are ending up with 800 million people who are food insecure. Right. So one, we talk about food insecurity or security, and at the same time we say that actually innovation will get crippled if regulatory oversight becomes too much. See, I agree, there need to be a balance. Now the balance, definitely we cannot be able to conclude this on this panel discussion. There will be different point of view, and the governments are involved. And luckily having experience of engaging with the government and working with the policy makers in multiple countries, sometimes actually we believe that governments are overstretching themselves with the policy. But at the same time, right, the world is not always very fair, right? So with the previous, I would say, instances where we know what has happened, right? A company which bought another company has to settle for billions of dollars, right? The suit we created in the previous one. I don't want to name the companies, right? But what I'm saying that we are having a history, right? And history always teaches us. So what I'm saying that those who don't learn from history, right, they are bound to perish. Learn from the history.
What lesson you take is important.
So, Tom used to...
I agree on that. Lesson what you take is very important.
Yeah, totally. And on your point, Deepak, I think each to its own. So I think all of the countries you mentioned, low capita income countries like Zimbabwe, Sudan, or maybe some of the Asian countries. So I think governments will do the best what is possibly for their consumers and the farmers. So we should have certain trust in the governments as well.
Exactly.
Just maybe a comment on the CRISPR technology and the way that some of the stuff is being democratized. Some people may have noticed we just licensed essentially for free the technology we've developed to the International Rice Research Institute. We've also done it to the International Institute for Tropical Agriculture and a couple of other institutes, again, essentially for free, so that they can use it for smallholder farmers for no cost. And those are government-supported groups that, as long as the regulations don't become a barrier, they'll be able to do things that can help smallholder farmers produce new crops.
Perfect. So I'll shift gears. Coming to you, Sefer, your data shows there's a sharp rise in M&A investments and partnerships across biologicals, crop protection, and seeds. So what do you think these patterns tell us where the competitive advantage in ag biotech is shifting to?
Can you repeat the end of the
Yeah, what do you think these patterns for investments, M&A and partnerships tell us about where the competitive advantage in ag biotech is shifting to?
I mean, I think up until, yeah, for this, so first of all, for this year, there's been a lot of M&A, but throughout agriculture in general, not just in biotech, but also in precision ag. So there's not a lot of difference. But when we look at M&As, partnerships, they represent about 40% of the developments this year that we've tracked. And what we're seeing is that there's obviously a lot of consolidation, but there's also a shift from a lot of these startups from being pure play solution providers. So they're introducing products like whether it's pesticides, herbicides, or new traits, into becoming platforms for enabling the release of new products. So that is something that we're seeing, especially since Q2 of this year, with a lot of new companies that are actually becoming enablers rather than pure solution providers. And that's where we see a lot of the investments and a lot of the VCs also shifting towards. Now, obviously in biologicals is a bit different. There's been a lot of investments in leveraging microbes, in leveraging microbes in order to enhance plant resilience as well this year. But overall, the main theme is this shift from being solution providers to being enablers for startups and all the developments that we've tracked this year in biotech.
Just to add to this, I mean, I was reading a Ag Funders report for 2024-25, I think, and agri-biotech, though there was a decrease as compared to last year, but still, it is the category that has got the highest investments.
Yeah, obviously, yeah.
Amongst agtech, right? So coming back to you, Tom, since you're growing a agri-biotech business, what do you think are the biggest challenges, I mean scientific, regulatory or societal, that need to be addressed for biotech-driven crops to achieve large-scale acceptance and impact?
Yeah, I think broadly in agriculture, we've talked a little bit about regulations here. I think it's challenging that the world is on multiple regulatory systems, but crops are sold globally. And that for many crops are sold globally. It's one thing we like about the fruit and vegetable space is because they tend to be regional businesses, so you can focus in a particular area, but then there are a lot of crops that are global. So I think, you know, it'd be very helpful if everybody could align. I think we're getting more and more aligned, especially around gene editing, that products that are produced that are the same as what could be made with conventional breeding. I think within a few years we'll have that, will be globally accepted that those should have similar regulations to conventional breeding, which are, by the way, are regulated. So all food is regulated. I think people make a mistake when they say that, oh, gene editing is not regulated. All food is regulated, and I think that's important that your food systems will be safe. But I think that kind of alignment across the globe is probably one of the bigger challenges. We've heard a lot of people talk about funding in agriculture, and I wish it were true that by being able to spell CRISPR that funding was automatic, because it's not quite that true. And it's, you know, these technologies take time, and they do take a significant amount of investment to develop. And we have not had a lot of successes to model after in ag. So even though, for instance, in healthcare and pharma, they take just as long and probably even more risk, but there's been successes that people can play off. So there's sort of a playbook that people follow in their investment. I think hopefully we'll see some companies make it all the way through the valley of death to the glorious other side in agriculture, but we have not seen a lot of those examples.
Perfect. And a similar question to you, Deepak. What do you think are the key policy or investment gaps that must be addressed to ensure that biotech innovations in agriculture can scale effectively and also benefit the smallholder farmers as well?
Yeah, sure. So I totally agree with him. First of all, we are having too many of, I would say, contrary clause in the regulatory environment across the globe, right? We need to, streamline that, because as rightly, articulated by Tom, the food is a global issue, right? So something which get produced in Ukraine is eaten in India, and vice versa. What is produced in India is eaten in somewhere in Netherlands. So until unless we'll have, even for biotechnology-based initiatives, common regulations, right? At least I would say that appreciate each other's regulation and understand what are the deviations, so we know what to be done. At the same time, actually, of late, initially, there was hardly any regulation in some of the countries on biologicals. When we talk about biofertilizers, when we talk about biopesticides and all that, because we assume they are harmless, right? And there was no regulation, and suddenly then you put them across in the regulatory environment without giving sufficient time for people to react, change. At the same time also now, because of this assumption, a lot of biologicals are fake, right? Because of that negative narrative. So narratives are very important in agriculture, right? So because of those narratives, now you have started seeing that the regulation in biological is far more than even the chemical, pesticide or fertilizer. Now I believe whether it's a chemical, it's a biological, it is anything else, right? You need to have same level of scrutiny, right, of any input which is going to the farm, because one, it takes care of livelihood. Secondly, it creates food which the world would be eating. Definitely when you are eating your chapati, you are not actually using any chemical analysis to find it out, right? How safe is your wheat? You believe that actually, as agriculture is regulated, you are assuming that if it is actually in the Lulu's supermarket, it would be edible and it would be safe. But it's far away from the reality. Even if you go with various reports, 80% of tomato consumed today, they are having more than 60% less nutrient what it should be 20 years back, right? So what you are paying for your food, you are already not getting sufficient nutrients. And this is what, again, I would believe the regulation has to be very careful about it. Second, you talked about investment in biotech. I believe more the merrier, because I always believe nature is the smartest way of solving biggest of the problems. And today's our problem is food security, nutritional deficiency. At the same time, we are also having problem with the livelihood of the farmers. And I believe strongly that the biology gives you the answer. And we need more investment coming from public sector, private sector, and also more collaboration between public and private enterprises, right? Because again, talked about availability of your tools, but we know that in CRISPR-Cas also, right, more than 90% of the tools are proprietary, and going forward and controlled by a handful of companies. Going forward, that would also be creating some of the challenges.
So 2 quick points. I think you mentioned that biologicals, they use naturally occurring microorganisms, and it is assumed that they may not be as harmful. So over the lunch, I was having this talk with Tom, and he told me sometimes the microbes can be as harmful as, the synthetic chemicals. So that's one. The second thing you mentioned that the biologicals, they are facing as stringent regulations as compared to the synthetic crop protection. Is that right?
Yeah. So what I was saying that previously we have a totally relaxed, right? In some of the countries, I don't want to mention those countries, but where actually you can sell anything by name of biostimulant or biofertilizer or biopesticide, right? There was hardly any regulation because you are saying bio. Because all the fertilizer control acts or pesticide acts, it's known as pesticide acts, right? Or fertilizer control acts. So by default, actually the chemical was a part of it. So anything which is out of those definition used to be unregulated, so anybody could have used it. And there were some challenges, definitely, efficacy was not there. There were problems of the crop process and all that. Now suddenly you become an overdrive. So you balance like a pendulum. You were too much on the right. Now actually because you were too much on the right, now you want to go too much on the left. So some of the regulations in some of the countries for biologicals, they are far, far more stringent than what it should be.
Please correct me if I am wrong. So countries like US, what I've read is that getting a biological, innovating it, developing it and commercializing it, it takes lesser time as compared to synthetic crop protection, and the regulations are a bit easier for biologicals as compared to the synthetic crop chemistry, right?
No, that I'm saying that actually the world is having too many different regulations. So when you go to US, in fact, some of the food which I'm exporting to US, Europe will not even touch it, right? The residue level MRLs, right? They are very different. The way they're actually evaluated, where they are certified, the traceability aspect of it. So Europe, America, Africa, Latin America, Southeast Asia, they are very different when we talk about as a region. So actually different regions have different nuanced issues. And this is where also I believe for those countries which are having good infrastructure for innovation, right? They're also having a little bit better regulatory mechanism. That's why they are ahead of rest.
Yeah, I would just simplify that there's a lot of things in the microbial regulations that are illogical connections. So like whether it could be easier to register something where you leave the microbe alive than if you purified the active molecule out of it. And how does that make sense? But that's the type of thing that you have to deal with in biologicals, and it's different all over the world.
Right. And Deepak, you talked about narrative in agriculture. So, Sefa, a question to you. Public perception still hinders biotech adoption sometimes. How do you see biotech innovations being communicated to investors and farmers to accelerate their adoption at scale?
I mean, obviously to farmers, a lot of startups up until 2022 have tried to prove their concept. However, since 2022 and the drop in funding, we're seeing startups also adapting their communications to farmers and talking about proof of concept at scale. And that is an important issue, is that a lot of companies come into agriculture with zero to no knowledge about agriculture, and they introduce a product thinking that, okay, it worked on a trial on a very small piece of land, it will work throughout the country, but actually there's no guarantee that it will work throughout the country, let alone within the same field next year. And so that is, so now we're startups, they're talking to farmers about proof of concept at scale and trying to prove their solutions throughout the entire field, not just on one part of their land. To investors then, what we're looking at is, obviously there's been a shift in between 2019 and 2022 where there was this big jump in funding and so on. There wasn't a big emphasis on return on investment. However, now we're seeing a lot of investors also asking about, okay, what is your traction? What are your current trials that you have? What is the money that we can expect? Because at the end of the day, we're in a capitalist society. So at the end, beyond all the sustainability and so on, if you don't make money out of it, investors are not going to follow through at some point. And so yeah, that's what we're seeing, and that's the shift that we've seen in the communication being done from companies to investors and to farmers.
Perfect. And that's very insightful. And probably a last closing question for all the panelists, if you would like to share your view, a slightly complex and a bold one. Could we envision a future where genomic data becomes an open source infrastructure, similar to digital public infrastructure for agriculture? And this is for democratizing biotech innovation. So I think in line with what Deepak said earlier. So your views on this?
So my views are already there. Like, we definitely need to have open public biotech infrastructure, and a lot of things actually, like, you create on top of what existed, right? And now we are looking at IP in a different way, what we used to see 20 years back or 25 years back or 30 years back. The norms were not that stringent and the copying was a norm, right? Now suddenly, like, we come in a scenario that everybody wants to protect their IP for a very simple reason, is that actually they use it as a deterrent as well as a valuation tool. But I think, like, food cannot be just seen with a capitalist mindset, because end of the day, like, if Google stopped working for a day, we might have a hardship. But just think of a scenario that actually, like, you don't get 9 square meals. 9 square meal is anarchy, right? That is what we are headed to. I believe, like, it is something of public good. Now, how it can be funded, that's $1 million question. But I think the need of the hour is that actually we start looking at that, where we put up open public biotech infrastructure.
So Tom, you're from a biotech company.
So if I understood the question about genomic data, I think genomic data already is a public resource. I think that I don't need to go pay to sequence anything to have all the information that I need, because it is already, and it's, the big genomic sequencing days where even if people did file patents, which were not going to be valid anyway, they have they're past their prime. So genomic data is a public resource now. I think the, where there are barriers in agriculture have to do with sort of large genetic resources that people have spent a lot of time developing. It takes a lot of cost and a lot of work to do that. I think they probably, even though I don't have that genetic resource myself, I do think that people deserve to have some kind of benefit from having the resource. But there are lots of rules in most countries around breeder rights and things that give people certain rights to those types of technologies. So I think it's probably more democratized than might look like from the outside. But you do need to, I mean, people do need to, at the end of the day, make money to pay for the next product, so you have to have some way that you're protecting them. But at the same time, again, most crops, there's an awful lot of free movement.
No, you're right, I think, and that's what Sefer mentioned. If you're doing a business, you also need to make some money. Yeah. And there is there needs to be a balance to, make the corporations make some profit, let the corporation make some profit, and at the same time, it should be useful for the major population as well. Yeah. Your views, Sefer?
As much as I would like to have some form of open source, whether it's just for biotech or in agtech in general, I don't see that happening, simply because there's a lot of interest, and also it's understandable. There's a lot of people that put on a lot of work, as you said, and they would want to have a return guaranteed and not have someone scoop on at the next minute and take all the benefits. But I think that maybe an area that we should look into is kind of limiting the number of years, for instance, where you can have this patent or so on that on your innovation for like 5 years or so on, and then it becomes available to the public. Maybe that could be an area where it would add some benefit. And I know that in the pharmaceutical industry, if I remember correctly, it is already kind of the case. After 20 years, there are some molecules that just become
generic.
Well, that's true. And maybe just one other comment is, we think that the barrier to entry, for instance, into the corn space is genetics. It's not. It's the reason I don't want to compete directly with Bayer and Corteva is because of the billions of dollars they've invested in seed production facilities and all the infrastructure it takes to get seeds to farmers globally. I could never do that, and that's not genetics at all. The genetics is actually pretty available.
Yeah, agree on that. So thank you very much, gentlemen, for very valuable insights. And what we have heard today is that biotechnology is not just confined to labs. They're like transforming boardrooms, farmlands, and even a kitchen table. And if we can, connect all these three, the innovators, the farmers or the growers, and the consumers, I think we are in the right direction, I would say. Thank you very much.
Do we have any questions? Yes. A quick one, please.
So when we talk about genetically modified, we're talking about also there's livestock, right? That's also another agriculture industry, and I worry about this because I know that I've spoken to farmers and they say, like, what happens when they start patenting their seeds, and what do we do then? Does anyone know what would happen then? Because genetically modified, we know for a fact this is done in a lab most of the time. So this is something that farmers, I know for a fact because I've asked them, and they're very worried about this. When they start patenting stuff, then what do we do then? What do the farmers do then? How do we go around it?
They buy the other seeds that aren't patented.
Pardon?
Buy the other seeds that aren't patented.
No, it's not going to happen that way. The elite will patent, and then we have a big problem, because it's always like that. When it's something's patented, you can't get past it. That's like Coke, just like Pepsi and all the other industries. By seeds, there won't be any seeds left. So that's not an answer to my question.
I don't understand.
Yeah. So you're saying that actually, the seeds which are patented, right? Farmers start paying more because they are patented. Am I correct? So farmers have to pay more because now it is patented seeds only.
That's not true.
No, that's not true. See, you might have not the same variety, but you'll have an alternative variety. And Pepsi you mentioned. So in India, Pepsi made farmers sign a document which said that actually they are giving these seeds for generating more seed and for their own production.
Just like
our code ensured that actually they said that seed is the right of farmer, and then Pepsi's case was dismissed. So the governments are there, courts are there. I think
it's just like over-the-counter medicines, that there are patented medicines and there are over-the-counter medicines. You can get over-the-counter seeds.
Thank you so much. So please give them a huge round of applause to all the panelists.